In basic probability approach, there is a coin, head and tail are two outcomes, and when you flip this single coin, the probability of having a head or having a tail is half. So this is a unbiased coin, so equal probability of happening is there. If we take two two heads, if you want to try two heads, when we flip two coins together, so two coins are flipped together, two coins are thrown, and what is the probability that two heads will appear? So basically, counting total cases, there are four total possible outcomes: head, 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 tail, tail, head, tail, tail. So there are total four possible outcomes, and the favorable outcome that we want is having head on both of them, which is just one possible outcome of the four. Now, when we go for the probability and multiply them together because of jointly happening event, one coin falls here, another coin falls here. The one coin which fell here has a probability of 1 by 2 for having a head on its face. Again, probability of having heads on its face is 1 by 2. So jointly the probability is 1 by 4. Similar answer is obtained with the basic formula, and with the probability joint event, same answer is obtained. So this was the sample space, four outcomes, and one of them is the favorable one, and two ways of finding the answer. Now let us change our perspective and see that this probability has changed. There is this biased case in which we are going to have more heads rather than tails. So this coin is, the weight is balanced such that you will when the coin is thrown on the ground, the higher chances are of receiving head. How higher? How much higher? 90% of the time you will see heads, and only 1% of the time you will see tails. The probability of head will be 9, and the probability of tail will be 1. So out of total cases 10, let's say 9 of them will be heads. Again, out of total cases 9 of them will be heads. So joint probability of having head on both the faces when two biased coins are flipped will be 81 by 100 according to our probability formula of joint events, and the including the biased nature. Now same thing can be calculated with the conventional thing that we have total, how many outcomes are there? 10 outcomes. So 10 outcomes here, 10 outcomes here, so 100 total outcomes, and amongst those hundreds, the favorable ones will be 9 times 9, so 81. So again same answer is obtained. So this is kind of a sample space theory in which we have biasing of the events. So why are we discussing this? We are discussing this because this thing generalizes into this formula, which is probability of having k successes in n trials, which is given by this formula. So let us go ahead and start seeing an example, and there we will learn how this formula updates applies to the binomial formula. So this is MET-902 design of experiment subject, and the question in assignment is that an agriculture cooperative claims that 90% of the watermelons are ripe, ready to eat, and the rest are not ripe, unripe. So first part asks us to find the probability of all 18 ripe and ready to eat. So out of the total number of watermelons sent, we have to find that all are ripe. So the n is equal to, so n is equals to 18. Probability of ripe is 0.9, and so probability of k successes in k trials, 18 ripe in 18 cent, will be given by binomial formula. 18 combination, this is taking all 18 in just one way. Then 0.9 is probability of success, the probability of ripe, which is to power k successes is 18, and not is 0.1 probability of not happening that, and not ripe, to power n minus k. 18 minus 18 is 0, and this is the answer. So let us have a good understanding on by applying both the biased and unbiased scheme. So basically we directly apply this formula. There is no unbiased here, this is by biased case already. So n is 18, and probability is this. We directly apply the formula, get this result. But now we have learned another concept in which we have a biasing. The unbiased case would be that there would be 50% ripe, 15% unripe. But here the case is that 90% are ripe. So out of 10, 9, let us say 9 are ripe and 1 is unripe. So 10%, 90%, same case happens, is given in the question. When we put all of them are ripe, so 0.9 probability to power 18 will give you the answer. So this answer matches the answer which is found by the formula. Next question is that we have 16 ripe amongst the 18, n equal to 18. Now what will happen now? What is the probability of having 16 ripe amongst 18? So it is at least 16 are ripe. That is the question. So if we read it carefully, it is at least 16 are ripe and ready to eat. So the equation becomes like this: ripe 90% given, n 18 given, probability of finding the ripe ones greater than or equal to 16 is given by directly by this formula. So choosing 16 or more will be 18, 16 out of 18, 0.9 to power 16, 0.1 to power 18 minus 16, which is 2. So there I have done it. Then 18 out in 17 and 18 in 18, and putting the appropriate numbers, you will get the answer. Similarly, probability of ripe less than 14, C part 2 is answer is given like this. And if you want to understand the biased case, you can also do that. So taking this case, a probability of 16 ripe and 16 of them, choosing 16 is the combination which has to be multiplied by this, and this is the case. 16 will be 0.9 and rest will 2 will be 17, 80 will be with 1 by 10 probability. So 0.9 and 0.1 probability, you add them up, and summation thing has to happen here also, and we'll get the answer. So the last one was at most 14 are ripe at most. So at most is ripe, that means that how much are ripe? At most 14 means ripe are up to 14. So you can also find it easily by doing lesser calculations by stating 1 minus probability of ripe greater than 14 is probability of ripe less than or equal to 14. So we again populate the numbers for the formula with the numbers, and we get the answer. Another question on the same formula can be given like this: 6 out of 18 new buildings are in violation. N is given as 4. The surveyman surveys 4 buildings, and this is the probability of violation. Find out none of the buildings that violate the building code. So this is the probability of OK and probability of violation. 6 out of 18 and is 4. All 4 test OK will be given by this. For all 4 test OK, probability of violation, and this is the answer. So B part is asking 1 fail in 4 tested, 4 in 1, failure this, and success is this, violation this one. This is the answer. Then 2 fail in 4 tested, check having this. So exactly 2 will be given the exact 3 or more will be given by 3 or more, like this, either 3 or 4. Fail. So this is how that can be done. Now question 3rd of assignment says the probability is 0.85 of fully charged digital camera battery which will take 150 or more photos. Find the probability that among 14 such batteries these things will happen. So 0.5 is the probability that the camera takes 150 photos. So 150 photos you can ignore, it is just information. You use the probability of taking a required photo number is 0.85. Now the batteries n is equals to 18. 16 batteries will take 150 pictures or more. So 16 will take 150 pictures or more. Again, 150 pictures or more is just the data which is here, and you have the associated probability 0.85. so 16 is exact number in 18, so we'll have 16 out of 18. Probability of this raised to the power 16, and 1 minus probability to this raised to power 2. So this will be the answer to A. Let us see how this has been put into formula. So exactly as we thought, 16 is to the power of favorable probability taking pictures greater than 50, and less than 50 is the remaining probability, which is raised to power 2, n minus k. So this is the answer after solving this. So this is exact 16, that's why there is no less than greater than sign. Next question, B part, they must have asked taking pictures greater than or equal to 14. So we will put the respective probabilities and calculate them and get the answer. In another question, probability of failure is must have been asked. So less than or equal to 2, again we put the numbers and we get the answer. So see, okay, this is the same kind of question. So we are done with this. Now let us move to question number 4 of assignment. In assignment, question number 4 is this one.